API service group. We're going to set up the XD laser on this machine to do a quick assessment of the X-axis. The XD laser is going to check 6 things at once: linear positioning, straightness in both directions, and pitch, roll, and yaw, all in one setup. That's the laser. Now I'll get the target. So I'm going to attach my optics to the machine. One thing you want to make sure is you have this little mirrored dot over the bottom hole. That's what you're going to aim for. Make sure you're good and sturdy. And also you want to be level to the world the best you can. You've got plenty of knuckles that you can adjust to make that bubble float right in the middle. And then line your sensor up to the beam. When you're close like this, you have both optics together, you always move the straight. You move the machine. When you're far apart, you're going to move the angles on it. But together, you move. When it's together, you move the straights, the machine itself. So get that right in the middle of that hole, and then run it down. See how you're good at the other end. So now again, when they're apart, I'm going to use the angle adjustments. Get that pretty close, and then bring her in. You may have to go back and forth 3 or 4 times to get these lined up just right. I got lucky this time. You want to maintain a rigid cord, at least on the sensor end. You don't want anything dragging, causing any issues with the reading. Now we can hook up the weather station and the extra level. This is a reference level that goes along with the level that's attached to the sensor. There's an electronic level in here, and there's one back here on this sensor. This one is just a reference level in case the whole machine's moving. And you can plug these in with the laser already running. Not a problem. Now the weather station, you're gonna have your material temperature sensor, air temperature, barometric pressure, and humidity sensor, all in this box. It's just a quick plug in. Very simple. Material temperature sensor can go on the table. I try to keep the air temperature sensor off of steel, just so I get a really good ambient air temperature. Then we have to hook up the Ethernet cable to the laptop. Now at this point, we can open up the optic and make sure we've got all 6 readings. Let me tie these up a little bit better. You don't want any outside influences on your reading. This is a pretty rigid setup. So I'm going to just flip this over so that both the optics are open, into the bottom, out through the top, back to the laser. Now we can open the software. Make sure you choose Ethernet. If you want to just look at your data, you can do offline data analysis. I'm going to go with Ethernet today. It's asking you for a CNF file. Your CNF file comes in a little jump drive in your case, and I keep mine in a folder on my desktop. It matches the serial number of the laser itself. Okay. Make sure you've got your remote control sensor turned on. As you can see, I've got all 6 readings, but they do need adjusted. So here's where we finish up the alignment. The XX to match the machine is going to be our Y-axis. And the YY is the Z-axis. That's all spelled out right here in this page. Sensor definition page. You've got a very good rendition of exactly how you need to be. Linear X, straightness XX, Y, straightness YY is Z. You can change any of that to match your machine. And you can also change the direction, which we're going to verify right now. So when I move the Y, I need to go positive to make that 0. Looks like I'm set up right. I like to be under 20 microns. So now I'm going to go to the YY, which is our Z-axis. That needs to go positive to get it to 0. If they don't match, you just go back to that sensor definition page and change the sign. It's that simple. Now, to change the angles, A and B, those are dials right here on the side of our sensor. Here's the A and B. I try to be less than 50 arc seconds. Now our roll angle is done with 2 sensors. Right here you choose this to see both the measurement and the reference. The reference is down here on the table. The measurement is up here. You've got an electronic level attached to your sensor. This is where being level to the world comes in handy. It helps you out tremendously. So you just try to get those close. I try to stay under 100 arc seconds and then try to get them close. I'm going to go for this number here. There we go. Now, sometimes it does mess up the straightness on the Y. Just dial it back in. And then we'll run the axis down to see how we're lined up. It takes a delicate touch. You just bring these in. Your XX is going to be with this side adjustment here, and your YY is going to be the one in the back, up and down. Try to get those as close to 0 as you can. Again, I try to be 25 microns or less. Okay, and then bring it back. It's important you remember the rule. You only adjust those angular adjustments when the 2 sensors are far apart. When they're close together, you adjust the machine. So here I'm within my 25 microns roughly. I could make that Y a tad bit better. Whoop. That's fine. We're ready to run the machine now. To set up for the measurement, you click XD. 6D, 5D would be for vertical. Your initial position, end position, increment. I'm going to run 0 to 2,000 every 200, 1 run. Bidirectional, automatic. You type in the name of the machine, the axis. Dwell time is a minimum of 6 seconds for the 6D. You can increase that, but you can't go any smaller than 6 seconds when you're going to collect all 6 degrees of freedom. The window I've got set for 100 microns. As long as your window is smaller than your turnaround at each end, you're okay. So, save save setup file, then you can name it right away. It's going to ask you if you're going to do a bidirectional mode. Yes, enable overshoot. So get X to your starting position, come to your software, hit reset, and start. If you forget to hit reset first, it's okay, because the start button will reset it. So I hit reset, start, and immediately it starts dwelling to collect that data point. And once we're good there, we can go ahead and collect the rest of the points. It moves, it stops, and then it dwells and collects the data. So here I'm at the last point, 2000. So I want to go outside the window and back, so I'll go another 10 millimeter. And once the software sees it leave, I can come right back that 10 millimeter. And it starts collecting data again on the reverse run. Now we're back to where we started. It will tell you that it's done. It says measurement is completed and data files are saved, which is nice that everything's already saved. So you hit OK, and let's look at the data. Open file. And here we go. You can look at the linear positioning. We're off almost 8 microns. Straightness, 7 and 8 microns. And the Y and the Z. And then the angular error, very small amounts, 4.9, 1.6, 3.9. And of course, you can manipulate these as well. You can change back to inch. You can increase the scale. And the standard, we go with the B554. So there you have it, all 6 degrees of freedom. The positioning, the straightness in the Y and the Z aspect of the X-axis, and then the yaw, pitch, and roll. Everything that's going to affect it is right here in one quick setup. Thank you for watching our video. If you would like to schedule an online demonstration or an on-site demonstration, please feel free to contact us at apimetrology.com to speak to a real metrologist today.